Welcome everyone, all 281 of you, according to the counter. I hope you're not too fried, right? A lot of content, hard to be lively before the end of this big day. So before we get into the serious thing, I have a favor to ask you. My son is turning 5 next week, and so I want to give him a little present, right? So I would like you to sing Happy Birthday to Maël. Are you okay with this? Yeah? All right. Happy birthday and then clap. He's never had so many friends in his birthday parties. All right, here we go. Happy birthday to you. Come on. Happy birthday to you. Happy birthday to you, Maël. Happy birthday to you. Woo! Amazing. Thank you, everyone. I think he's going to like it. We'll see. So, yeah. So, SSO. I'm here to talk about SSO. That's me. I'm Daniel. Is this clicker working? Yes. So I'm Daniel. Hi. I'm a software engineer, like most of you, I guess. I work for VMware in the Tanzu Spring org, so I do a little bit of open source Spring on Spring Security, Spring Authorization Server. And I work on the Tanzu application platform, which is the platform that VMware has for deploying apps. You give us your Git repository, you end up with a URL in the end with your app running, and I work on the SSO component. So, you want SSO, I'll give you the credentials for SSO using this. Here are all my socials. Reach out. I'm always happy to answer email, messages, pull requests, and reach out in the hole if you want, because that's the most valuable for me, the discussions. So we're going to talk about SSO today, and we're going to be doing code. But before we do code, I'm sorry, we'll have to see a few diagrams, because this thing is a bit complicated. Who has been to an OAuth talk here so far? Oh, maybe like 15 hands. Not bad. This is a different take on it. So we'll go back to the basics for those who've never heard of this, and then a few diagrams, and then code. So OAuth OpenID. What even is this thing? So OAuth is an authorization framework. The auth in OAuth is authorization. The idea is to grant permissions to some apps so they can go talk to other apps to obtain resources like pictures, your calendar, and so on. This is achieved by exchanging a thing called an access token. And of course, OAuth is a list of specs. So we can go scream. I don't have the Victor's soundboard, but like you would usually scream here. Come on, Firefox, come back. Okay. Oh, it's on Chrome. That's why. So the specs of auth, right? Chrome doesn't want to show them because it's awful. And a spec is an RFC, so there's 70 pages of this. And we don't want you to be implementing this. Usually you would use a library for that, right? So that's OAuth. An example of OAuth is something like Daniel, or the meatbag, the resource owner in the terms of OAuth. I grant permission to, for example, myphotobook.example.com, which is like a photo printing example site. I granted permission to access my photos that are stored on Google Photos, for example. All of this without sharing my Google password. That's OAuth in a nutshell. And you notice here, we don't talk about identity at all. There's nothing about myphotobook.example.com. It gets my photos. It doesn't get my email, my birthday, so on, right? And so that's why we have another standard, which is OpenID, and it's a framework for authentication, so that myphotobook.example.com can know who I am, can get my email. I can do SSO with auth, right? I can have a special resource on my Google Photos that tells, it's called /me, and then I have some information in it, but it's not standard. Whereas OpenID has a thing called ID tokens, and in ID tokens and in some endpoints, I have information about who this is. And we have other specs, which we're not going to go and see. All right, so why do we have this? Like, why does this exist, and how does it work? So if you think back at the example of myphotobook.example.com, I want to grant it my Google Photos, and a naive way of doing this, of achieving this goal, is to give it my password, my credentials. So here's my email, here's my Google password, go fetch the photos for me. So of course, I imagine all of you have this, that this is a terrible idea, you don't want to do this. For multiple reasons. So one, it wouldn't be convenient, because if I spread my Google password all over the internet, and then for some reason Google changes their password rules and I have to change it, and I have to go to 15 sites and change that. But most importantly, this is like a security nightmare for many reasons, right? I want to give my photos to myphotobook.example.com. I don't want to give it my email or my calendar or my contacts or my whole life or my Google Plus when that still existed. I want to give it my photos and my photos only. And most importantly, myphotobook.example.com is a site that was developed by like 17-year-old Daniel in my mom's basement, and it runs on a Raspberry Pi under my desk. So this will get breached. And when this gets breached, I don't want the attackers to have my Google password, right? So that's the whole motivation, right? We want to be able to share some things, but without sharing our credentials. And we do this with OAuth. This is not OAuth. This is a representation of what happens in OAuth. So the idea is Daniel, I go to the authorization server, so accounts.google.com, and I'm going to grab a token, an access token. And this token will have permissions, but just for my photos, and maybe just reading the photos. Maybe I can't delete them, right? And then I'm going to give that to myphotobook.example.com. And myphotobook.example.com can then use this token to retrieve my photos. And the token is short-lived, it has less permissions than my credentials. That's OAuth. This flow can somehow happen. What happens usually is OAuth recommends you use the thing called the authorization code flow. So instead of doing that, two types of token, we'll go back to this. You exchange a code. So code is like the smaller version of a token, and it lives for like 1 minute or 5 minutes. I give that to myphotobook.example.com, and it's its responsibility to exchange that for tokens, right? Two types of tokens. So we have access tokens, ID tokens. So when the client app obtains an access token, it can exchange it for resources. The ID token is mostly for itself, not to authorize with something, but rather to like know my email. There's my email in my ID token, so they can spam me with promotions and so on. All right? And so when we do SSO, mostly we stop at this, right? We have no resource server. In this demo here, we have a little bit more time, so maybe we'll go all the way to actually using an access token to exchange it and implementing OAuth. Sound good for everyone? All right, so enough slides, talking. We want to see some code. And because I hate myself, I decided to prepare this in 3 languages. So we have a Python version, a JavaScript version, so Python in Flask, JavaScript in Express, and Spring and Spring Boot. And so I need you to choose. And to choose these, well, I mean, I could make a Slido and make you vote, but I prefer making you some noise. So could you please make some noise, those who want to see this in Python? Yay. Okay, Python is like, this doesn't feel like a Python conference. Okay, what about make some noise for JavaScript? Woo. I kind of had a hunch that this would end up being who wants to see this in Java? That's it? Who wants to see this in Java? There we go, right. Well, I had a hunch, right? Java police. So we're going to code this, but before we do, I'm Daniel, and this is live coding. Don't do this. Don't do this in production. This is a terrible idea. I'm going to bypass so much of the security that is in this that you don't want to push this code ever, 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 right? Use a library. This is for you to understand what we're going to be doing, the endpoints we add, and so on. All right? So we have, happy birthday, Maël, very good. We have a Java application. So I should go into Java, boot up IntelliJ, and then while this boots, I'm going to start compiling it continuously so that it refreshes over time. Continuous, can I type continuous? There we go. And so this presentation mode, this is a Spring app. run it, and localhost. So it's a very basic app just to have some infrastructure to have a page to show. So a page, not authenticated, and then a button to log in as a hard-coded user. So you can see what it looks like when you're logged in. Log in, log out, right? I don't even have to type username and password. And we're going to add SSO to this. So just to show you kind of what this is, and then I'm not cheating, we're going to have the dependencies. Yes, load me the script configurations, but in the dependencies, you can see we have Spring Web, Timely for templates, and then the rest is like development dependencies. And I don't have a Spring security up my sleeve. And so what does this login look like? Well, basically it's a post to the /login endpoint, and this lives in a controller. There is a login, which gets or creates the existing session. Is the font size all right for everyone? Okay, so it lives in I take the session and I create it if there's none, and then I put a username attribute and I put an attributes attribute with a few, hard-coded things. And the index page basically gets the session, and if it exists, it shows me the authenticated page, so this one. And if it doesn't exist, it shows me the anonymous page, right? So we need to add SSO to this. So when you think about it, I told you that you would go and obtain a code from Google. But when you log into your, I don't know, train app or your expense report from your company, you don't go to Google first, right, or your Azure directory, right? What you do is you go to the website, right? So how does that work? Well, the website has the responsibility to tell you where to go and fetch that code. How can you authenticate with me? How can you authenticate with myphotobook.example.com? And so the way it does that, it tells you, go to accounts.google.com, and then come back to me on OAuth2 callback, for example. So it's not a standard, it's just a convenience that tells, well, it's going to be OAuth2. If I want my redirect URI to end with like foobar, foobar is fine. Okay, so we need to craft a link for the user to go and click on so they can log in. And here when they're anonymous. So let's start with maybe an empty string. So we do a button. So login URI is empty, and then we're going to add attribute login URI, and then we use it in the anonymous thing. We create a button. Going to use timeleaf. So this is login URI, and then call it SSO, and timeleaf needs this. So when I go back to Firefox, I log out again. I have an SSO button that does nothing because there's no link for now. So where do I go for this? Initially, I had the demo with Google, but since we may do an authorization server, I want to be able to customize more things, customize the scopes, and so on. So our good friend Matt Rabel would be very happy I'm using Okta. And so we need to find the authorization server, which is here. And if I look on it, it has a special endpoint under well-known OAuth authorization server. So I can click on it, and it tells me how it's configured. So there's an endpoint. If you're doing OAuth, it's under OAuth authorization server. If you're doing OpenID, it's under OpenID configuration. This one has both. And it tells me several endpoints. We want a code because we're using the authorization code flow. So the endpoint we want to send the user to is the authorization endpoint. So I'm going to copy the link, right? And then in the controller, use that. So URI components, component builder from a URI, this one. Nope. And then in this one, we do what? We ended up building it. And then we need to pass it the redirect URI, right? We need to tell the Google or Okta in that case, when the user is done logging in and they're happy with the SSO flow that we're doing, send them back to me on OAuth2 callback, right? And then we also need to instruct it. What we want to see is what type of authorization flow we're doing, because there's multiple types. And so we say what the response we want is a code, an authorization code. And there are other things. We can discuss them, but this is the most common case that you do here. You also need to pass it a security thing, the state, which is kind of a anti-CSRF protection. You don't need to really, we're not going to be using it, but like Okta will reject my request if I don't do this. And then the last bit is, I told you OAuth and OpenID are or OpenID is based on auth, right? So if we go back to the endpoint here, the OpenID endpoint, this one, it has an authorization URI, which is the same authorization URI that we have here. So we have to tell the authorization server, we have to tell Okta, this flow, I want an ID token. I want identity information about the user. And this is requested with permissions. And in auth, to request permissions, you request them with the scope parameter. So you're saying, I want, for example, like, I don't know, google/photos.read, right? If you want to read the photos of the user. If you want an ID token, you use the OpenID scope. And then if you want more information in the OpenID scope, there are a few standard claims, or standard scopes you can put to say, hey, also I want the email of that user and that ID token, okay? If I do this, and I save, and I go back here, right, and I click on SSO, it doesn't work. Why is that? When you think about it, anyone could send this request. Anyone could try and initiate login against my site. This is bad, right? I don't want anyone to send authentication traffic to my site. So Okta has to know myphotobook.example.com. Myphotobook.example.com has to be registered with Okta. So I need to create an application. There we go. Applications. Let's create a new one. OpenID Connect. It's a web application. Next. And it's the same. The same exists on Azure, on Ping Identity, on Google Cloud, on Keycloak. I'm going to call it DevOps. And then I need an authorization URI. And in the slides, we said it would be OAuth2 callback. And I can have one for localhost, I can have one for my prod site, staging site, and so on. And then I'm going to add my user to it. And it creates it, and then it comes back to me with two important things. One is the client ID that identifies my app, and that's a public thing. And one is a client secret, which is really secret. And that this one, no one is supposed to see it except the apps that actually use that. So we're going to store those. Private final string, client ID is, no, go back, is this one, yes. And the client secret is the other one. This, yes, perfect. And so I need to pass the client ID, otherwise Okta rejects my query. Client ID is client ID. And when I'm saying this one is public is because on this link that I create, we can't really see it at the bottom, but it has, when I hover over it, it has the client ID, right? The browser can see it. It doesn't have the client secret. So hopefully, if I click here, I go to Okta, and it explodes because it succeeded. If you go back, what's exploding here is my Spring app. We're going back to OAuth2 callback, right, with a code. So we have obtained a code. So according to our flow here, we need to give this code to our running application so they can exchange it for a token. So to do that, it's very simple. We have to create a new endpoint. So it's a redirect, so we do a get mapping on OAuth2 callback, we said, I think. And public string OAuth2 callback. I'm great with names. And then for now, I'm just going to return a redirect to the main page without doing anything, just so that it doesn't explode. So if I go back to my website, I go here, it redirects, nothing happens, right? I click on SSO, nothing happens. So I want to grab the code and I want to display it. Code, and then do a proper logger, don't do this, it's fine. Code. Cool. You should always put emojis in your presentations because this way it always breaks because of character encoding. That's great, trust me. Okay, code. So I should open this, and then when I go here and I click on SSO, we have a code. So we capture the code. And now we need to exchange that code for a token. So we need to go to the token, the token endpoint, the thing that gives us tokens on the auth server. And the token endpoint is called the token endpoint. Like not very original. They're as good as me when it comes to naming. So we need to call that thing. So I have a REST client with a new Spring variant of making HTTP calls. And I'm going to do a post on it, because the spec says do a post request with the code. And the URI is going to be the token endpoint. Beautiful. And then we need to do multiple things. We need to pass a body at some point, and then we need also to authenticate with it. Because this is my photobook.example.com. It's an app that Okta knows, and it needs to prove that it's really this app, that it's not someone that intercepted the token and is trying to use it. How do we do this? We do it by passing the client secret. We could pass it in the body, or we could do HTTP basic authentication. So we're going to do that. This happens with a header. The basic basic HTTP authentication is usually you base64 encode username, password, for those who don't know. This is what we do. And so in here, the username is the client ID, and the password is the client secret. So let's do just that. We're going to do creds. This is going to be client ID plus plus client secret, right? And then we're going to base64 encode this. By the way, this is so, like, I didn't expect that, but this is so nice to write in Python. Python is made for this kind of demos. Encode this to string, beautiful. And it's unhappy about this because probably it takes bytes. Yeah, sure. So basic plus the creds. And then I need to send the code. So we're going to create a payload. Because of serializations and APIs and so on, I need to use a linked multi-value map, which is the easiest thing, of string. It doesn't matter. What you're doing is like you're creating a form encoded URL string, and then sending that. So in that payload, we're going to put the code, add code under the code. We need to put two more things. We need to put the authorization, the grant type, which is basically in OAuth. I told you there's multiple ways of obtaining a token. This flow is called the authorization code flow, and you tell it like this to the auth server. Sometimes in OAuth there are no humans involved, so it's a different grant type. No one can go and log in. Sometimes you log in on your TV by scanning a QR code, so it's a different grant type again. So this one is the authorization code grant type. And then for security, this code is bound to the redirect URI, so I also need to know the redirect URI that I used here, this one. So I need to send it again for security reasons. I'm going to make a field, redirect URI. And then, I'd rather do it somewhere else. Here, beautiful. Okay, and so I use the redirect URI here. Okay, payload, and so it serializes nicely. I'm going to tell Spring to use the content type application form encoded, the famous x form URL encoded. Okay, so that it makes the nice, or the body that the authorization server expects. Okay, and with this, I can retrieve the response, and then I'm going to put it in a string, because YOLO. And this is the token response, thank you. And we can print it to see what it looks like. New lines, and then response, that's good. Response, right? Plus token response. Okay, so if that works, come here, SSO. So if it doesn't blow up, I mean, it works. Warm up a little bit, fine. And yes, we do have a token response. Woo! So we need to do something with this. In this token response, there's an access token, which is this thing, and then there's an ID token, which is this thing. So we need to look at this ID token. Let's extract it and take a look at it. So we need to deserialize the response. I'm going to use a token response record, token response, and then this one is going to extract from ID token. Is going to extract the ID token as a string ID token, right? And from the access token, because we may use that later, I'm going to extract the access token, right? And so I take this token response, and do I have an object mapper here? No. Okay, create one. Again, like Python, poof, just call JSON on it. It doesn't care what type, so fine, types what for. New object mapper, perfect. And then the object mapper needs to be a bit lenient, so I need to tell it, well, if there's more data in in the thing you're trying to deserialize, don't blow up, please. Just deserialize what I'm caring about. And so we say fail on unknown properties false, so that it extracts the ID token, the access token, and doesn't blow up. Plumbing. And we're going to read the value from the token response, and then we're going to put that in a token response record, so a class. And this is going to be, say, parsed response. Why not? Okay, and this, of course, this can blow up, so exceptions. Whew. And so in the token response, maybe we want to extract the ID token. We said ID token. Well, actually, it's in the parse response. So we can say token. I use a cookie for a token. Token, and then parsed response dot ID token, right? So we print the ID token in the console. All right, so I go here, refresh. Should not blow up, beautiful. And so in my console, if I go to the bottom, it says token. Here it is. That's your token. So effectively, we've taken the code and we've exchanged it for an ID token. Good. But this looks kind of gibberish, right? There's no email in here, or it's very well hidden. Who knows what this is? Yeah, JWT. Yeah, base64 encoded things. So this is a JSON web token, JWT. It's 3 base64 encoded things. The first 2 are strings, and the third one is bytes. And that's separated by dots. So the first bit is the header that tells you how this token was secured. So it's signed with, here in this case, RS-256 which is RSA with SHA-256. The payload contains the data that we care about, and then the signature is to verify the integrity, which we're not going to do right now. So I'm going to take this token, and if I want to inspect it before I actually, use it or try to decode it, I can go to the famous website jwt.io. This one here, and in here it tells you don't paste your tokens everywhere. No, it's fine. And so I'm going to paste it. I copied it. I'm going to paste it here. So I have a header and told me it was signed like this, fine. But what I care about is the contents of the token, the payload. And then the payload, it tells me the person that logged in is Daniel Garnier Moiroux, that's me. And their email is that, and a few technical claims. And you could, if I had set up Okta, I could have my picture and my profile and my preferred username. Oh, preferred username is here. Cool. So I need to decode that thing. So let's go. We take the parse response.id token, and then we split the thing according to dots. I'm going to take the dots and I'm going to chop that up, and this is going to be the token part, or call it parts. And we want the middle part, right? So the payload is going to be base64 decoder, this one, decode me the part number 1, the one in the middle, so the second part. Beautiful. Ooh, I already had a payload somewhere. Okay, let's call that body. Fine. Ooh, BD. Hey, so we have a payload here. It's decoded, and then I'm gonna also well, we could print it out. That's fine, actually. Let's see what it looks like. So a box, payload, a plus payload. Okay, so I go here, SSO, and then in here. Well, this is a byte array, so it's not super interesting. Let's make a string. Go again, SSO, code, payload, right? So the thing we've seen on jwt.io comes back, and I can extract the name and the email. So now all I have to do to show something to the user that they actually logged in is to go and extract the username and the attributes. So I'm going to do that. So we need to put them in the session, right? When I log someone in, I put that in the session because I'm not using Spring Security, which you should. But, what's the fun in using libraries? So here's the request. We're going to grab the session. And if it doesn't exist, create it. Fine. We have a session, and then we can put the username in it. So set attribute username to payload get name, right? What is it? Rename payload? Oh yeah, types. Who cares about types? String. There we go. And what is this one complaining? Oh, I haven't read it. My bad. Okay, thank you. So this is the string payload, and then what I want is like the decoded payload. Decoded payload. Object mapper, read value from the payload, put it in a map, because, you know, types, whew, overrated. Why do we do Java? Okay, perfect. And then I can, from the decoded payload this time, I can get the name and put it in username. Beautiful. And then in the session, I can also set an attribute for, I call them attributes to show what's in the token. And I put the whole decoded payload here, which is a map. Okay, and so if I've done my job correctly, I click on SSO, and welcome, Daniel Garnier Moiroux, that's me. Here's Daniel, here's what we know about them. So, you know, a lot of things that are technical. So for example, which authorization server gave me this token? When was it issued? How long does it have to live? But what I care about is the identity data, basically the username. Okay? Sound good? Do we have any questions so far? No? So does it say anything about my role? No. So role is not a standard OpenID concept. There's no role. If you go to the spec, there's no role. In Okta, there is I think in Okta, they can give you a groups property. So these properties, they're called claims. I think in Okta, they're called groups, or maybe roles, I'm not sure. And you can, but you have to go and click through the UI. If you go to Microsoft, it's called groups. If you go to some other provider, maybe it's roles, right? So it's not standard because this is mostly for authentication. The roles are usually used for authorization. And so usually this is achieved through the scopes in the access token. But oftentimes there are roles, like Microsoft lets you put the roles because everybody uses that for basic authorization. Even though the concept of OAuth is more, should be in the access token. So speaking of access token, in here I have a second button, conferences, which when I click, it doesn't reach my backend because it's not started. So let's go to the resource server in Java. Open it. Yes, I want it in a new window. Cool. And then I'm going to start it, and I am going to compile it so that when we make changes to it, it restarts. So the resource server is a simple HTTP API. Is it conferences? It's a list of conferences. So this HTTP API can be used by the front end. Here I'm using a hard-coded ID. So it's -1, so I get devox and then a fake conference. Basically, I have a lightweight repository called a map, in which I have conferences per person. So the user -1 who doesn't exist went to devox and also to fake conference. And I went to these conferences. Okay, cool. And so this I can call it, you know, it's just an unprotected API server. So I could call it with AT81/conferences user ID equals -1. So if I get -1, I get the fake conference here. What? Oh, AT80. Yes, I have it. Perfect. The other page is not protected either. And then Okta at Garnier.wf, which is my name. I can get that one. So what we want is we want this page to be secured with an access token, right? So I don't just pass it like this user ID. So let's do that. So in here, we are going to save, when we log in, we're going to add the access token, call it access token, and it's in the token the parse response access token, right? And I'm going to send that to the conferences microservice. So instead of hard coding -1 here, I'm going to send it. An access token is sent through a header. So it's sent through an header called authorization as well, but it's not basic, it's called bearer. So we had a header, we say it's called authorization. It's called bearer, right? And then here we're going to say request, get session, and then get attribute access token, right? So I shouldn't be showcasing this, or I shouldn't be calling that if there's nothing in the session, but for shortcut, it just blows up if there's nothing. Cool. In my resource server, then I use this access token. So I'm going to remove that. I'm going to hardcode -1, so it keeps answering the calls. And from the request header, I'm going to get the authorization header, right? And from the authorization header, I'm going to remove the bearer part. What I care about is what's after bearer, so the access token. And so replace this with an empty string, and the access token comes back. So the resource server can see it. And I'm just going to print it access token. There we go, and access token, right? So now, go back. I'm going to log out because I want to grab an access token, put it in the session, which I wasn't on that site before. Click on conferences. I still have my fake conferences, but now when I go to the resource server, I have an access token. Okay? So in here, I want to decode that access token, see what it looks like, and then decide something. So remember we had an ID token here, which had my name, email, preferred username, first name, last name, birth date, profile picture. This access token is much smaller. It doesn't have identity information. The only identity information it has is the subject. So who is this about? If you use a Google vanilla access token, you don't have the email, you have like a number, which is unique per user. In that case, Okta has decided to use my email for reasons. And inside it has the scopes that were requested. Okay, so we're going to take this and we're going to grab the user out of that. So again, record, we're going to call that payload. Payload is going to have a string. So sub goes into subject. And while we're at it, I'm also going to take expiry, put that in an integer, sorry. That's expiry, and then also grab the scopes because I want to do something with them. List string scopes. Right? So in here, just like we did with the other JSON web token, we're going to split this thing with a dot, and then grab the parts, and then do I have an object mapper here? No, I don't. Private final object mapper, new object mapper. Thank you, IntelliJ. And then in the constructor, configure it. Object mapper, deserialization feature, plumbing. That's the configuration. With deserialization feature, fail on unknown properties, false. Beautiful. And so now I can split the part, and then I can base64 decode the part number 1, the one in the middle, and then I can object mapper. I can read this into a payload class. So now we have the decoded payload. Of course, it can fail for many reasons. Never fails with me. And from the payload, I can grab the subject. And the subject here, if you remember, it's going to be okta@garnier.wf. Go here, refresh, and I have my conferences, the one for that one subject. Okay? This is absolutely insecure, right? Because the site, the My Photobook, the conferences, this site here, could make a fake token and send it to me, right? And with a fake name in it. So I need to do a few things. I need to verify that the token is right. I need to verify its signature. I need to verify the scopes in it. And I need to verify that it's not an old token that someone grabbed from some logs from 3 months ago. So we're going to start with the easy ones. So first, from the access token, we get from the payload. Sorry, from the payload we get the expiry, and this is seconds. So take the seconds, and is that before now, right? Is the expiry in the past? If it's in the past, it means the token has expired. So I'm just going to throw a runtime exception expired. Okay, if this happens. So my token should still be good, right? So if I refresh here, unless I wait for, I don't know, an hour, I think it lasts for an hour by default, it's not going to blow up. If I had changed it, if I change my condition, here in that case, after a refresh, there we go, boom, it explodes, expired. Okay. So my token is valid in terms of expiry, of timing. Then we can check the scopes of it, right? Because now I'm not, anyone can any website can do a client, like register itself with Okta and then try and access this. But maybe I want to like, scope down the request. And so just like with the roles in here, we're going to get the scopes, and we only are going to accept the request if in the scopes there's conference.list, I think I called it. So I pre-registered the scope in Okta. I created it. I put it. So it knows that's not the standard thing. I created that. I could have sandwich.eat if I want, or like :eat, whatever. This is non-standard. OpenID was standard. Email was standard. Conference.list is not. That's my invention. So if it's not in the scopes, then this is going to blow up and say scopes. Sure. Go here, refresh, boots up, and then it fails with scopes. Because you remember, we went, and in the scopes, we requested profile, email, and OpenID. So the client application must be using, what is this? The client application must be requesting the scope. And this happens at this stage, conference.list. So when we send the user out with a login URI, when we send them to Okta, we say we want OpenID email profile. This is very useful because the user can see that I requested the conferences. So, they would need to go and look at the URL, or most authorization servers do this. Back, log out, log in again. I'm already logged into Okta, so I'm going to do it again in a private window, AT&T. Most authorization servers do this. If I'm not logged in, Okta, super secret. No, that's not my password. What's my password? I think I got it. Did I get it? Right. So most authorization servers do this. They say, ooh, you're requesting this conference.list scope. And it was configured to have a name and have a description. So when I went to Okta and when I created the scope, I called it, this is a view conferences. Obtain the list of conferences you have attended this year, right? So as a user, I could click cancel and say, no, I'm not giving you this. And so the client application could be like, ooh, no. That's what you get when you log in with Microsoft. And you should read that message when it says, oh, by the way, it wants to access your calendar, the train booking thing, maybe to put events in my calendar. But like, I don't know, the photo app should not be able to access my calendar. So allow access, I get the scope, it gets put in the access token, and then I can attend the conferences again, right? So these were the easy things to do. The more complicated thing that I'm going to do half manually here, which you shouldn't, again, you should be using a library here, is verify the signature. Because here, if I'm a bit crazy and I craft a token, right? I craft a header, I craft a payload as JSON, I base64 encode them, I put a garbage signature, I send that to the resource server, the resource server reads it and it's like, yeah, yeah, you have a subject, fine, I'll give you the conferences. So we want to check the signature. The signature is in here, is defined by this. So there's this key ID, and it says this is a signed token. So we did public, like asymmetric cryptography. The server used a private key to generate this signature. And the server also gives everyone their public keys, so the signature can be verified. So the resource server can say, oh, this token that came in, it says that it was issued by this authorization server that I know, that I trust, and it says that it was signed by this key. So if I go here, there's a JWKS, which is JSON web key set. So if I click on it, I can see the keys. And by looking at the key IDs here, they match, right? This BL3 is here, BL3. So the auth server used a private key that has this ID and then signed a token. And here it's giving me the public parts of the private key. So I can reconstruct the public key and I can verify the signature. So we do this. I cheat a little bit because cryptography is a bit, dirty to do from scratch. So first I'm going to grab the keys. I have this helper method, get keys. What it does, it makes a call to this, and then it constructs, it gets the motors, the exponent, and then it creates a key spec, and then it uses the key factory to blah, blah, blah. So usually you would never do this. You would use a library like Nimbus that does that for you, or whatever does JWTs. So here are the keys. And from the keys, I want to find the signing key. The key that was used to find this token. So I can say in the keys, you're going to filter the keys and you're going to find me the key such that key ID equals the header of this. So I need to decode the header. Let's do that, right? Record, header, string, kid. So we decode the header, var header equals object mapper, read value base 64, decode, or the URL one, the first part, so the header, okay? And then put that in a header.class. So, boop, JSON comes in, header comes out. So that header, it's equal to header.key idea, and I trust that it will find it. Find first and get, sure. This is the key, so this is the signing key. And with this, I can verify the signature. So again, these are like not super friendly APIs. So I hide them in a method. So signing key, public key, and then we're going to need to pass it what data was signed, and then the signature. So the signature is easy. It's the base 64 decoded part of the last part of the message. So parts of 2, right? So I take it, I decode it. And then what's missing is the signed data. So what was signed? In order for my token not to be altered by anyone, the header and the payload are taken together. You put a dot in the middle and you sign this string. So the signed data is, I said, header. So the header is parts of 0 plus a dot plus parts of 1, the payload, right? And that's the signed data, right? And I need to get bytes, sure. And this can blow up. And this gives me a Boolean. So if you want to see this verify signature, it just like gets a signature factory, and then it calls some APIs that you can find about online. So this, we could make it in a variable to make it readable. Is this valid? So if this is not valid, throw new runtime exception, you cheeky prankster. So we're going to blow up with this. So this, it's a valid token we're using here, right? So it should be working, right? It's still working. If someone tries to create a fake token, fake news, right? If someone sends me a fake token that they have created, but they don't have the private key of Okta, so they can't sign it, they send me data they created, but the signature is wrong. And so in here, fake news, right? You cheeky prankster. Okay? So in 50 minutes, we have implemented the authorization code flow with which we have obtained an ID token. We have implemented the authorization code flow with the access token that we send to a resource server that validates it. Remember, do not do this, ever. Use a library that has many stars on GitHub, because that's a good sign of security. If you use Spring Security is your go-to library. I'm Daniel. It's been fun. Grab the code. Come to me for feedback in person. And I have 2 minutes for questions. All good? Right. Thank you very much. And come.